This is Science Quest. With your host, Jed Allen Friels. He's taking you around the world, discussing everything science.
Hi, I'm Jed Allen Friels, and thanks for joining me on Science Quest. Today, we're at Dinosaur Valley State Park, just outside of Glen Rose, Texas. And we're hoping to meet up with my oldest son, Austin Friels, who's working on a research project that involves, you guessed it, dinosaur footprints. So let's head on into the state park and try to find Austin.
Hey, Dad. Welcome to Dinosaur Valley State Park. Need a ride?
Yeah, buddy, where are we going?
Well, let me tell you what we've been digging on today.
Great.
Come on in. This park's famous for the river that runs through it, the Paluxy Riverbed. And in the riverbed are all these different types of dinosaur tracks, ranging from sauropods to sauropods and flesh-eating, plant-eating, all different types of dinosaurs. And in the trackway in the river, it's eroded away the different tracks, and by brooming away the sediment that's layered on top of them, we can see the outlines of the tracks and document the animals as they moved throughout the river. Now, at one time, this was the old Gulf of Mexico, way back when the dinosaurs used to roam the earth, and they walked right across the shoreline. And there's a fine line between the water and where they walked, and if they walked right on the line, you can see their tracks, and they got preserved. So that's what we're doing, uncovering the tracks, and then tomorrow we'll go back and see what we uncovered after the river does some fine cleaning, and figure out what we're looking at. Hey, we're down the river on day 2 after cleaning out these tracks. Yesterday we scooped out all the stones and the junk that was inside the track so we could see the depression. Now today, we're going to use the broom and get the sediment washed away so we can see more toe depressions and see the actual orientation of the track and if it's really one animal or not. And we can track it all the way through the water down through here. So these are pretty good tracks. The ones that have not been documented yet, we'll get them documented today and get them in the system. And hopefully later today we can find some that are out of the water so we can get a closer look. So after we get them cleaned out, swept out, and all the rocks are gone and the silt's moved away, the next step in the process is to photograph them and document them so you can look at them back in the lab. Now when you're photographing footprints or anything in the field, you always need some sort of reference. So this field guide right here will set down right here. You put that in the picture, just a standard 15 centimeters. Remember, we always use a metric system. And make sure that's in the picture when we take the picture. Photograph all 3 individually, and then you get them all together in one trackway. Now the next step, take them back to the lab, and we can look at them in a little bit better light. So now that we've tracked the sites, GPS'd them, and we've figured out their specific coordinates in relation to the river and via satellite, we can go up and take some photographs just so that when we put the data point on a grid, we know what we're looking at. So it's not just a dot on a piece of paper, now it's a dot on a piece of paper linked to a picture from up above. You can get a better scope of the trackway that way. Now usually when you're photographing, you want to photograph from straight down. The riverbed's a little uneven, so the best we can do is get off to the side, unless someone can bring a helicopter in. Now, our storybook is complete. We can move on to the next track site. We've seen some nice underwater footprints. Now, it's a little bit hard to get a plaster cast from when they're under the water. Now, when a footprint's above water, and you can clean it out really nice, you can lay this plaster in and get a nice form fitting of what the footprint looks like on the inside. Now, this helps us with a lot of things. You can see how deep the depression is. Each animal has different toes, different characteristics of their specific footprint, which helps you individualize whether it's one animal or 2 animals. Also, you can tell about how big the animal is by how much mud's pushed out of the way and all these other variables.
Hey Austin, let's go to the main track site.
Let's check it out. Hey, we're here at track site 2 today, still in Dinosaur Valley State Park. And it's a great place out of the water where you can see some good examples of some 2 different types of tracks. Now the first type of track is the type we've been talking about all along, the theropod track right here. It's really defined with a heel, and it's got 3 long toes, kind of like you'd think of a chicken. The chicken's foot, they think, is a descendant of an ancient reptilian or maybe even dinosaur type animal, so they have the same type of features and they walk in similar ways. So you can see the outlines, only it would be a very large bird. And it steps right here with the right here with the left, and probably has another right up in here. Now interlaced within that track, there are different types of animals. A plant-eating animal called a sauropod. Theropod, think of Tyrannosaurus rex. Sauropod, think of your long neck, long plant-eating dinosaur. So their tracks are much bigger and fatter down in the water right here. Here's a better example of a theropod track. You can see it has toes as well, 5 toes, kind of like we do. It's got 1 here, 2, 3, 4, and a little pinky toe up here. Obviously, the inside of the track, right here, was where more weight would be pushed down. So you know this is going to be its right hind leg. Its right hind leg sits more deeper here. The front leg footprint was right here, but the front footprint gets covered up because they always step with their hind leg right where they stepped with their back leg, kind of like a horse would, or a deer. And so when they step down with their back leg, it scrunches the mud up into that hind footprint, and usually it's lost. There are 1 or 2 front footprints that can be found that are really nice because the dinosaur was standing still. So this is an old dig. This is where everything was cleared away. There's been a new spot that's been eroded recently. We can go over and check. We just excavated it out. And it's still roped off until we can get good documentation of it, which we need to do fairly quickly before it erodes away even farther. The type of material that it's in is a shale type of substrate. And once it's opened up, or once the dirt is taken off of it, then it erodes away very quickly. As you can see here, it breaks up and breaks apart. So these new tracks back here that have been eroded, we've been brushing out and sweeping out with tools. And now they're the same type of creatures. You still have the back footprint, the mantis of the sauropods. You still have the theropod footprint and meat eaters right here interlaced within each other. This is a really good example of a front foot of one of those sauropods. It's a lot smaller than the big one, but it was standing still at the time. Here's my dad finishing up the last few broom strokes on one of the really good new sauropod tracks.
So hey, what an adventure. Dinosaur Valley State Park. We're taking a look at prints from the past. So remember, the answers to your questions might be in a footprint that was over 1,000 or maybe even 100,000 or even older than that. Remember, that's what we're after. The quest for knowledge sometimes can be found in everyday things that we see every day, and sometimes they're in things we see from the past. Hey, I'm Jed Allen Friels, and thanks for joining me at Dinosaur Valley State Park, Glen Rose, Texas, on Science Quest.